Alright, hello everybody. Let me get adjusted here. Up at me. I'm going to lose the edge of my screen, but whatever. That should work. Is audio working? Everything good? I had to rejigger things in my office, so I don't actually have the ability to hear Discord chat today, sadly. Otherwise, I think we should be all good. Alright, so last time we left off, we were playing around with succinct data structures. We were trying to get a form of like binary serialization for Haskell where you could write the data out to disk, but then when you go to load it back up, you would only pay to access the portions of it you actually looked at. So you would like memory map the file and then just get everything working. The thing that we managed to accomplish last time was we were able to build a data structure that wasn't necessarily optimal, like it doesn't have all the sum of products kind of stuff that I would like, and we were able to build the index, but we weren't able to get that index out to disk just because we ran out of time. We ran for like 8 hours last time, and I don't remember, 2 or 3 hours the time before, so I expect today we should be able to make a dent in that. 1 second here. Let me switch over to the coding view here, which doesn't have anything on it yet. Also, let me see if I can bring the light level up in here a bit. Maybe fix the green screen problems that I'm having. I'm getting a bright spot on the one side, which is this way. I moved everything around in my office the other day, and all of a sudden, the screen behind me is not in the right position. Bugger all. Maybe if I pull this closer. There. Looks better. I still have a bright spot over there. Whatever. Now I'm very, very bright. Maybe that brings me down a level. Probably too much. And thank you, Husla. Yeah, this has been kind of a whirlwind tour of a bunch of my little pet toys, propagators and succinct data structures, and we did authenticated computation and like starting to build a library for dealing with commutative, applicative functors and stuff like that. We'll probably do a session just cleaning this crap up and like shipping it. I'll probably move that to the week or something like that if we can. So let's see here. Where were we at? Am I Shrek'd? Oh no. Filter. I give up. I'll just be bright. It's these very bright lights. Alright, where the hell was I going before all of this? I was going to start a terminal window. And I've been trying to get back to the CEK machine stuff. One of the things I really want to have that work is to have Nix and Ada work very, very well. And Brian McKenna, Puff and Fresh on here, has been doing a ton of work to make that happen, and we're just not quite there. So I think once I can get the Nix and Ada working together properly, story all shaken out, then we'll get back to CEK machines. In the meantime, we're playing around with succinct data structures. So again, today the main thing we're going to try and do is get a library for serializing binary data out to disk in a manner that let me see if I can adjust that. There we go. That lets me only pay to deserialize the portions of it I actually look at. So abusing some tricks from the succinct data structure world. So I guess we'll do a quick recap. Let me first of all blow this up large enough to... Come on. You'd think I'd have this all set up magically by now. There we go. Not quite sure what you mean by unaligned bits. RSADs, we're just about to do a recap of what we did on the last couple of streams and kind of explain the idea. So I'm just going to write a little text file here, and we'll see what the heck a succinct data structure is. So, like, if you had a random bit vector, some bit vector that had n bits, k of them are ones. There are n choose k such possible bit vectors. So you could write down which one of them you have in a number that takes log base 2 of n choose k bits. But when this thing was a bit vector, one of the things you could do with it early on was we could ask, like, what's the value? Is the value of, is the, like, ith entry in the bit vector? And yes, I can try and bring the mic closer. See if that helps. Testing 1, 2, 3. All right, I think I'm just barely breaking into the yellow. That should possibly be good. Did that work for you, WorldWake? Closing that. And yeah, the problem is the way I have the mic stand set up, it's off to the side of me, largely because if I mount it there, then it gets all the tappita from the keyboard. So I brought the mic about a foot closer, which hopefully should help. So this doesn't align to bytes. This works on, this whole thing is designed to bit serialize a lot of crazy stuff. We're going to use the succinct data structure stuff in order to do binary serialization. So right now what we have is this like notion that like if I wanted to access the ith bit of a thing, we could read it out. But if we were to compress it into this form where we just told you what n and k were, and so then if like k was very, very small or n was very, very large, this would be a much more efficient encoding than storing the raw bit vector. This would be much smaller. So what we talked about last time was that if we like talk about this amount of entropy, the amount of information inside of this bit vector, in a amount of space h plus little o of h space, something called succinct space, we can still support access in constant time. So we're adding an extra term that it's not like saying big O of h. It's not like saying like this is a like one. That's not like saying 3% extra overhead. It's saying no matter what percentage overhead you're willing to accept, as your data gets large enough, eventually I'll beat it. And then it's also possible to, since we're asking for a pony, we can ask for a really kind of tricked out one. This is the number of alphas in my in S, where I'm one indexing. That's what I was doing last time. Starting from position 1. Is the position of the ith alpha in S. So alpha could be 0 or 1. So this gives us, these are the tools that we can do with a succinct indexed dictionary. So there exists a data structure that has these properties. I built a little succinct library. John Key and Alexei Raga, as Haskell works, built up a bunch of stuff. Alpha could be 0 or 1 here. At the moment. Later on, we'll deal with like things where they, or in the first session, we dealt with things where they could be where you could have a larger alphabet, where this wasn't a bit vector. It could be a string or something like that, and they could be symbols, characters in your string. So, and then last time we talked about a bunch of things that related these. We said that select is left adjoint to rank if we kind of ignore alpha and s, if we fix those. And that, like, if you were to do something like count or select the position of some alpha in my string, select the position of the ith one, and you were to ask for the rank in that thing up to that position, it should be I. And on the other hand, if you were to select alpha s, rank alpha s I, this would be less than or equal to I. So these are like all of the extra kind of conditions that we can start talking about here. We can say like rank alpha. Let's just do concrete things. S I is I minus rank 1 si and vice versa. So we've got a bunch of extra laws and conditions and stuff like that we can use to reason about these things, just by talking about operations on these bit vectors. Okay, so this is the idea of a succinct index dictionary. There's also a notion of a succinct binary tree, which takes 2n plus little o of n bits. It doesn't have to be a binary tree, to store an arbitrary, like, rows tree with n nodes. And you could sort of encode this as like storing the bit vector of the balanced parentheses. Like if this was to represent a tree that had 2 children, they're being represented by the balanced parentheses for these children and then the balanced parentheses for the surrounding root. And then if you were to think of opening and closing parentheses being zeros or ones, this would take, this would be a bit vector where I'm using n choose n divided by 2. And so this is going to be, in the end, we're going to store every node with 2 bits. So this is the space bound on storing binary trees this way, and it turns out that there's ways to navigate up and down this binary tree in O1 time. So we can store a tree in compressed form where it only takes 2 bits plus change per node, and we can still navigate the tree. So last time what we did was we took a version of like data.binary or something like data.binary in Haskell, which is a binary serialization library. And we said, hey, look, we could, if we were to serialize, I don't know, 1 to high or something like that as a Haskell, as a stream in Haskell, then something like binary is going to spit out 1 and then 2 and then like the length of the string and then the characters for high or something like that as a byte sequence. Like these are going to be, they're going to be full integers. So they'll be, 4 bytes, 4 bytes, 4 bytes, then that, or something like that. Potentially 8 bytes if you're dealing with, a 64-bit platform. But if I wanted to decode, let's say I was walking down and these things were very, very large, and I only wanted to pay to decode the portions of them that I looked at. Like if I were to serialize this thing out to disk, I would want to be able to deserialize just the portions of this that I inspect. And my use case for that last time was to talk about something like a Haskell interface file format, where when I write a Haskell interface file, I tend to write all the types and all the modules, and all the information I need about them. But then when I go to use it in type checking later, I only ever really look at a couple of pieces inside of it. So the fact that I'm spending all of this time paying for stuff I'm not using is the thing I'm trying to fight. Like I'm trying to fight the deserialization time. I would like to just memory map in the file as a gigantic blob and then get something that can walk inside of it. So to do that, what I had to do was separate out like the data that we have here from the shape information. So what's the shape here? Well, the shape here is sort of like we have at the top level, we have two kind of regions. Inside of here, we have that. So here's where the data goes. It goes in these kind of big open bins. So I need some kind of metadata thing to kind of let me interleave shape and data. Like I have shape, data. Like, you know, let's say that they're 4 bytes long. For the one, shape, data, 4 more bytes worth of data. 1, 2, 3, 4 bytes worth of shape here. Then we come back and we have to serialize 2. And then we have to serialize the last couple of things, and then we're done. Okay, and the idea is that with this index and the ability to use rank to walk down into the data and the shape, and use select to walk up from the shape back into the data, and the ability to navigate the system of parentheses, we can make it possible for us to deserialize and only pay for the portions that we look at, but only pay a small amount of overhead, not the size of, like, what's the offset of the second thing? Like, if I stored a batch of offsets, I could do this too, but it would be bigger on disk. Okay, so that's the general mission that I've been playing with for the last couple of days. I hope that wasn't too much of a whirlwind tour for folks who are new. I mean, I realize it went pretty far, pretty fast. The last couple of sessions are online if you want to dig in more on that. The 1-2 sessions ago, where I talked about just succinct data structures, kind of introduced all of these structures, and then used the rank and select to walk up and down a bunch of things. The session last time was a kind of marathon 8-hour stream we did. How big of a difference in the size savings is it going to make? Well, if you were to store a binary tree made out of pointers, those pointers are going to be each like 64 bits long. So it's about a factor of 32 in storing binary trees. So this thing is about a factor of 32 smaller than it would be otherwise. And this thing is roughly like an 1/8 or something like that of the size of the original data file. So, and this is going to have like 2 things for every one. It's a sizable difference. One of the things, if we get around to it, we might go back and play with using succinct data structures for big aggregate data queries and stuff like that, which is sort of an interest of mine. I never have packaged up as a package. I was doing it as a consultant for a little while and then kind of dropped it after that wrapped. So we have, I think all this is consistent. But if you're interested, yes, this has a name. It's called the Succinct Indexed Dictionary. We go to Wikipedia and we Google for succinct data structures here. There's the notion of a succinct data structure. And if we look here, this is the z plus little o of z bound that I said was succinct. And here's their definition. Rank q of x is give me the count of how many x's there are. And select is find me the first position, or find me the x q in their vocabulary. And again, there's a representation that takes n plus little of n bits with the original bit vector, but there's also a fancier version that takes optimal space, which is this succinct bound. So in general, the succinct data structure stuff isn't new. It's used a fair bit inside of the like compressed string search space. Like if you were trying to take a document or something like that and you wanted to have a full text index on it, like if you were to do this in kind of like the Google style reverse index kind of mess, it's going to blow up and it's going to be several to 30 times larger than the original. On the other hand, if you use this sort of Succinct encoding, it kind of takes the same amount of space as b-zipping it, plus a term that's negligibly small, and you can do full text indexing in optimal time. So that's one of the uses that this thing gets put to, is something called an FM index, which I talked about a bit a couple of sessions ago. So yeah, so there's the ability to ask these questions about rank, and then we can entropy compress this thing to fit in optimal space. So what I'm doing right now is I'm using a library that John Key and Alexi Raga did, well, a set of libraries, and I've started building something on GitHub at github.com. You commit succinct binary for those of you who want to follow along at home. Let's see what we have here. So that's the library that I'm currently building. I've dumped it to chat. Kind of taking a tour of it so far, what we have is the notion of, if you look at data.binary or serial, they kind of have this general structure of package, serial. Let's look at that. And in here we have like a data.serialize class. Data.serial is a module that supplies a serialize class, which has the ability to put and get like arbitrary Haskell data types. And then has a crap load of instances for how these things serialize products and lists and all this kind of stuff. But the idea of needing some way to put and some way to get is pretty universal here. So I copy that structure, and when I'm putting, now I'm not putting out just the data, I'm also putting out these meta index of is it shape or data, and this shape thing off to the side that I'm going to use to navigate. So we built this put monad last time, and we built up a bunch of internal machinery that the end user should never, ever, ever see. And here's an example of our, like one of our metadata indexes for this, almost the exact same example that we just wrote out in that little text file. And built some combinators for scribbling out parens into the metadata index and into the shape. And then built a class for things that we can put. And then we built a whole bunch of stuff for GHG generics in order to serialize that for pretty much anything you could possibly want. So there's a bunch of stuff that say, hey, look, you can now just write instance puttable one, maybe, or something like that, and it'll just derive it as long as that thing's an instance of generic and isn't made out of weird things. This has been the general shape. We built this thing for putting. We built a monad for getting. So get takes, we scribble out all of that stuff into something that we just called a blob, which has some kind of the metadata, which is that bit vector with some kind of structure we call, which is we talked about last time, which is a poppy index on it, which is not trying to be succinct. Technically, this is compact. It's like it stores the original bit vector and then adds like an extra 3% overhead, but it's fast. And then we built a structure for the shape data, which is something that we know how to navigate with the parentheses. And then we stored the content just as a raw byte string. So we built our little put monad. We can run it and spit out the answer that whatever our put monad was going to compute, and the blob that is the archive of all of its contents. I don't actually need to wire this up to optics. One of the things we're going to get out of this is that you'll just get a data structure that is lazy, and it could be enormous, like in a gigantic map or something like that. And then just the paths of it that you actually wind up inspecting as you look at parts of that map will get deserialized. In order to make that work, though, we would need a version of data.map that was lazy in its branches. And so map out of the box won't work. So we'll have to build a notion of a lazy map and some things in order to make this more usable for like the original kind of design goal. Apparently drinking out of a green cup on a green screen is. Alright. So what do we have here? So what we were doing before was like we were using the existing builder functionality from byte string to just build up byte strings as we go, rounding them up to an integral number of 8 bytes for the meta and shape data so that they could be vectors of word 64s. And then converting them into these structures that the all of the HW rank select and HW balance parentheses libraries need. So this is all the Haskell work stuff that the data structures that we're dumping them in. And then once we have a blob, then the get monad goes through and uses the blob and an offset into it. So this is an offset into the metadata at the top, which tells me where we're at. And then there's a bunch of things like if you know how to get from the left-hand side of the pair and get from the right-hand side of the pair, here's how you get from a pair. This uses the ability to navigate to the first child and the next sibling of a thing, and then to select, to rank to walk down from the metadata into the shape, do something to the shape, and then select to walk back up. And so last time we were able to build this class forgettable things, and then we were able to test it on a handful of examples. Nothing terribly earth-shaking, but it did seem to work before we left. The things I really want to work on today is that this does not try and spit out an optimal tree shape. It tries to build, it just naively uses the sum and product structure, like pairs of products and pairs of sums, and it would be much better if this was smarter. So I would think it would be fun to go through, and not fun, it would be useful to go through and try and convert this to more of a sum of products generics style. And I don't actually know how we're going to do that. We could use, there's a library for generics SOP or SOP generics. This library exists, and so this is Andres and Edsko, and they gave a talk on this at Zurahack a year or two ago. Generic programming with, yeah. Let me just dump the link to the YouTube talk. So this whole thing winds up one gigantic flat buffer with shape, data, and whatever like being contributed. So like as you go down the tree, it's going to have all of that's going to get serialized into the same stream. If that makes any sense. All right, so that's I believe the link to the Zurahack talk. I don't recommend watching it right now because otherwise you're going to miss everything I'm doing. And like last time, I'm not exactly familiar with all the code I'm going to be wiring together here, so you'll see some of the exploration process. I'm not necessarily wedded to using generics SOP to do this. There is some support in here for so given one of these things, you derive GHC generic, and then you instance his generic. And then, so I'm not actually, let me install generics SOP. I'll just add it as a dependency here. Get this thing to build. Drink from my transparent cup. Come on. And it didn't. I really should bring a faster machine in here to stream with. So there's from and to in his terminology. This is just rep of A. All NF data X and P. Gurnf. What is all to for every element of a list of lists? So what I would like ideally would be able to use this thing and then just say, hey, all to put or something like that, and that would be the way to derive generic put. This would hopefully let us throw away all of the GHC generics crap that we built. I'm not necessarily sure if that's good or bad, but I do generally want to be able to say, hey, look, here is the, instead of having the tree of pairs, like this is the first of 5 constructors would be much more efficient because then I can just write out the tag as one number rather than a sequence of numbers, which is logarithmic in the number of constructors we have. And then also, like, when I have products. So let's just look at an example here, I guess. So if I had some data type foo equals A or B or C or da-da-da-da. I don't know. Pick 8 letters in. Let's just go D, E, F, G. Let's do 8 letters. All right, this gets encoded as in GHC generics as is that one of the first 4 constructors or one of the latter 4, and then it gets broken down further, right? So it becomes like a sum of, and then in here it gets broken down further into a sum of, and then at this leaf, 1, 2, 3, 4. I need more leaves, right? 1, 2, 3, 4. Yeah. Da 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 da. With a whole bunch of extra stuff inside of here. And so if each one of these is going to take up a byte worth of my input, it's rather wasteful in terms of the encoding of the shape. So SOP generics, on the other hand, say that if you look at an algebraic data type, it's a sum, this outside thing, of a bunch of products, whatever fields these have. So this would be a sum of products where this first one had 3 things in the product. So I believe SOP generics gives everything back as a list of lists, where the outer list is the sums and the inner list is the products. And it just decodes one layer of your algebraic data type. What is the SOP generics module? Generics.sop. What do we got? Sum of products I, the code for that thing. And what is an SOP? An SOP is an NS of NP with some F X's. What is I? I is identity. Code is all of these instances that say, hey, look, you know, for, I don't know, let's look at some of the examples of these, because these are actually quite pleasant. Identity it just gives you back a list of lists. These are like type level lists, so this is like the type level list of the arguments and stuff like that. How do the individual constructors work? Constant is just the first one. Composition has one field, and that field contains the composition, the nesting. Bool is a thing with 2 constructors, but they each have no arguments. Ordering has 3 constructors that each have no arguments. Maybe has 2 constructors. The first one has no arguments, the second one has 1. Either has 2 constructors. You're getting the general shape. Unit has 1 constructor with no arguments. Pairs have 1 constructor with 2 arguments. And then that looks like all they've bothered to implement for the most part. Oh, lists. Lists have 2 constructors. The first one has no arguments. The second one has two arguments, one of which is a value, and the second one which is a list. So that is the idea of his code type. And then, so if we were to from 1, 2, 3, we would get a sum of products, which is suc of 0. With this. And this is, so this is, I believe, the which constructor we have. So which of the two constructors we have. So it's the second constructor, it's a const cell. And that const cell had these fields. All right. Yeah. Let's see if we can build this using data binary succinct put. So what do we need? We need this puttable class for all the things. So in order to use that mechanism, we would want to replace this default put with a different one. We want default put where we've got G generic A, G puttable. No, not G puttable. Something like all two. Put code for A. This would be what I want. Instead of using our old generics path, this would not be GHC generics. This would be SOP generic. Let's call this SOP.all2. So last time we were fighting around with all this generics code and it was just monstrous. And I'm hoping that if we use the sum of products thing, we can make it A cleaner and smaller. We have SOP generics, SOP all2, put all this crap. So now what we need to do is something like this Gurnaf's example. Put is go from now we just build go. Sum from is going to be something like SOP Z X's. We're going to start with 0, I guess. SOP ZX's will keep track of an accumulator. Put word 8 for now. The accumulator, we'll just assume that we don't have ever any more than 8 constructors, or 256 constructors. Lie. And then what else do we need to do? Then we need to product X's, whatever that is going to be. Sum and accumulator suc X's is going to be sum act plus 1. Don't really like having to rewrap it in SOP, but whatever. I believe that's plausible. And how do we handle product? So this is already wasteful. We're not detect when we only have one constructor. So what are we going to do with the product case? Well, now we have a product of things. If it's nil, this is going to be nothing. We're going to do nothing. Product I x constant x is going to be something like put x, then product x's. But then we have a problem because this thing needs to know. We need to actually put the surrounding parens around this thing. So put the parens around the product. And then we're going to put parens around each here. And we want this outer put parens around this. Okay, so what would this give us? This would give us something like, here's an outer paren, I'm constructor 3, then, like, let's say constructor 3 had 3 different fields. This would be field 1, field 2, and field 3 of that thing. This would be the generic serialization format. And then what we need to do is know whether or not we are unary, or if we're something that has exactly one constructor. And then in that case, we will skip the putting of the constructor number. So that will change the sum case. So I guess what we need to do is, where's all 2 defined? To learn all this stuff. All zip, compose, no, and no, coercible, no, none of this. We can build it all by hand. I'm just trying to see if it's already here in the library. All. What did all 2 know? All 2 knew that we had an slist I. Slist I gives us some kind of length. All right. I'm going to flail around here a bit longer. What else we got? We've got generics SOP. We're going to get out a list, but it's not a list. It's a sum of products, and a sum of products is an NS. NS is one of these things. Again, an S list said, you gave me a type level list, and I will reify it. So what I should be able to do is I should be able to ask for S list of the outer thing. So the goal here is I need to count constructors. And all I have right now is, like, at the value level, I only have a thing that is a number between 1 and n, where n is the number, or 1 and n minus 1, where n is the number of constructors. So the first thing I need to do is count how many constructors I have. And in theory, I should be able to do that by looking at this S list from just 2 was the type of that? That's an SOP of I of that shape. S list takes any proxy x's and gives me back a thing. So if I were to do something like length s list of this thing, booyah, I can just do it off of the SOP, because proxy is lowercase proxy, so it pattern matches on anything, and so SOP blah blah blah, this crap acts as the witness for that thing. Ugh. Okay, so I convert from this thing. This is giving me the SOP. And so we're going to compute length S list of the SOP. If there's zero data constructors, we blow up. If there's one, we put out the number of what we have. Actually, we don't need to blow up. This will blow up in the normal case. Sum 0. Otherwise, we're going to do something like, this is going to be case SOP of, it's got an SOP and it's got a single Z. Put the parens around the outside of this, and then we'll just do product x's. Okay, so we're looking to see how many constructors we have. If we have exactly one constructor, we skip writing the tag. Yeah, so version data structures is a bunch of stuff that uses serial and binary for doing like versioned data. I'm very deliberately leaving that open for now. Mainly because I don't have anything interesting to say in that space, I think. And it's crushingly boring to work on. This is bad enough. Yes, you should version all your data and all that. My eyes glaze over. So now we've done that to do. So we are, in theory, looking at our original string, building this thing called from x is 0. Analyzing it, putting parens around it in this case. Otherwise, we are doing this recursive thing. And this should be strict in its accumulator. That would be nice if that just worked. I have some concerns that this all2 needed this in order to construct all2. Oh, it does have it as it has slist_i as a superclass. Thank goodness. And this is going to be from the SOP module. Do we have anything else that's coming from the SOP module? I guess we have SOP's SOP type. Anything else? SOPZ. There. Maybe I can get rid of all these scoped, qualified, messy imports later, after we can maybe kill more of the needs for GHC generics. Why the strict annotation there? Because otherwise what's going to happen is this will accumulate a big thunk and then force the thunk when we go to do this put word 8. This way it'll build it up as a machine integer during the recursion. It might be smart enough to spot that put word 8 is strict in its argument and that you always somehow get to that base case, but I don't think so. So this bang annotation says sum should be a function that is strict in its accumulator. You sometimes will see, like, inside a GHC code, like ACK body is something like ACK seek body seek this kind of nonsense, and this would be, you know, be strict in this, be strict in this, and then, yeah, this case can never happen because we're going to give back, like, this is conditional on this thing being true. This would return false, but then this would force me to be strict in ACK. That was from an era before bang annotations. Second line of the definition of sum that I missed. I do believe you are correct, sir. Thank you, Taneb. In theory, this would have just done everything. I don't really want to require their SOP generic. This drives GHC generic, but then, see, I want to just use GHC generic and then say, screw it, figure out how to do the thing. Because otherwise I'm going to make users write extra instances, and screw that. So while, Andres, this is beautiful, I think me having to use your generic class is almost a non-starter. From here lives inside of this thing, and it has G from this crud. Default from is G from. So I'd like to replace the use of SOP's generics with something like this. This would reduce the constraint to something that would be instantiated out of the box. GHC generics. G from. Hey. It's gonna be from SOP. All to SOP put G code A. And then this would just be a slight change to using G from. And then we would get to use the SOP generics code without having to, yeah. Hello, is it Leaf? Welcome to the stream. All right, I think we have a plausible story here. If we have length 1, we are skipping the serialization of the constructor. Otherwise, we're doing all of this nonsense. In theory, this will have let us use all of the stuff from SOP generics without having to incur a dependency on the SOP generics class, I'm hoping. And all new build. We'll set up a GHCID thing to keep trying to rebuild this thing for us. That's travel schedule stuff. Let me grab a window that isn't being used. What's the command again? It's GHCID-C. Ball new REPL. All right. This doesn't know about bang patterns. God damn it. Did I not import SOP qualified? .144. SOP. Oh. G would actually be pretty, GHC would be kind of nice for that, but SOP.G from, but that came from like an internal module somewhere, and I will hope to hell the generic stuff is exported. Generics SOP. G from lives in GGP. Generics SOP GGP. See if we can do that. So we require put all to put tuple. Pattern matching on an algebraic data type requires GDTs or type families. Sure. Not in scope. G from. Comes from SOP. P1 against type put. I've got a word 8. And then we're going to take a something with an SOP. Let's go look at the earlier example that was buried in the SOP generics code. So it's like all to NF data. Not in this case NF data, it's all to puttable. All to puttable X's. SOPI X's to a put. And product is going to be an SOP all puttable, and these are going to be SOP, SOP, getting really repetitive. SOP all puttable x's, SOP np, SOP I x's to a put. Monad put m. What did I call it? Put word 8. I think I give it a name, put 8 locally or something like that. No instance for GOP B1. Damn it. That should be an instance. GSum from V1 should just be there. Damn it. That looks like a bug in SOP generics. Or, let me go look at GSum from. Because you should be able to build the GSum from. We should just not be able to, like, if you had a void, you can build a thing with 0 constructors. GSum from. Where's GSum from? That sounds very generic. GSum from, GSum to. It's just missing the V1 case. Now I'm going to be annoyed because this GSum from thing is not being exported, isn't it? God damn it. I really don't want to have to copy and paste all of your code, please. Given an A of X. Handle products. When you hit the M, you're done. So, why are we failing? We're failing because void on line 189 I'll rule this case out for now. The import of data.void is now redundant. Well, it's not redundant if this thing wasn't missing a case. Case SOP of 148. I do believe it is redundant, or it is perfect. Binding of some come up with a nice name. I'll go up with one later. $149 probably needs some kind of polygons. Nope, I screwed up somewhere. Case SOP of product do I not need polygons? Nope. Do I not need data kinds? Nope. And yeah, it's a green cup. And hello, Corwin. Actually compiled. Holy crap. So it'd be kind of nice to just be able to kill all this puttable 1 crap. So I think I'm going to go down this road and see if we can just... Is there generic SOP for generic SOP 1 or something like that? There's just... He only has first order version of that. That's fine. I'm actually not sure why that's failing to distinguish that it is impossible to do the other cases. GHC used to be pretty good about that, and then I don't know what happened. That's all dead. All of that puttable generic stuff that I had written before dies. We kill the puttable 1 class. All that stuff dies. So in some sense, our co-opting of GHC generics shrank a lot of code. Or SOP generics. I don't really, Corwin, I tend not to like the, foo random uppercase letter thing. So in this case, I'm dealing with the sums. Now I'm dealing with the products. It seemed good enough to get out of the namespace. Do I have HLint installed? I'm not using lambda case. What else am I missing? Not using lambda case in here either. Alright. So now we're going to do the exact same thing for get. So get is going to have this leap in complexity, but then we should be able to get rid of all this generic gettable shit. And what I should probably do is I have that put thing. I'm going to call this thing gput. And then yeah, that should be legit. Huh. So we have puttable, we have gput, we have putn, all that crap. And then get, I'm going to want to open up put just so I can see the crazy signature we had there. We'll be able to build our gget in the same way. Qualified generic SOP. Here's all the shapely crud that we needed for this thing. Ggettable will die. So gettable is here, good. gget looks like all of this stuff, but returns a get a. Then this thing dies. We define gget. And then eventually we kill all of this ggettable nonsense. And we'll get a more efficient representation. And so what we're doing today is we're building a library in Haskell for serializing Haskell data structures out to disk, but then deserializing only lazily as you access parts of it. And we're using a scheme something called a succinct dictionary, or succinct index dictionary, in order to get that disk encoding down as small as it can be. And right now we are switching from a form where we were dealing with just binary trees and binary products and everything in order to serialize our data, and making it work in the kind of same native shape as the algebraic data type. So we're using a library called generics SOP to replace a lot of the stuff that I was writing directly with GHC generics. We're kind of way down in the weeds of writing stuff with Haskell in a very generic way so that we don't have to write it over and over again. Okay, so let's see, how did we do put? So we need to build a sum of products. I don't need anything in particular. I can use sop.gcode. Proxy of... It's going to be a proxy SOP G-code of A. So we'll just magically look at the thing that doesn't exist yet. Using gget and split off the cases. So in the case where we only have one constructor, get doesn't have to do anything for the symbol to say which constructor we're in. So we're just going to build how do we do this? We're not putting parens, we're not navigating up and down. We need to walk through hand over hand through each one of these things. The walking to the kth child doesn't matter. The only thing that's going to differ is constructing from the list, like the, what is it? It's an SOPI for this particular. We're going to wind up with an SOP of I of G code A that we need to build. And then we're going to take this thing and convert it into an A using 2 from SOP. So we're going to build all of this stuff up, and instead of casing on the sum of products, which doesn't exist right now, we're going to handle the products for x's with the appropriate type, magically. Then we're going to stick this thing, and then SOPZ, and then SOP. Then we're going to SOP.to from that. All of this mapped over whatever products wants to do. and then we're going to need to read out the number here as well. No. We'll deal with the non-unary case later. Products, X's. I need to know where I'm at. So I'm in products is going to build a get monadic action, which has access to the blob and the current index. This needs to build up a appropriate sum of products to put together. So all of these things, SOP all, of the, everything here is going to be gettable from the data store. It is, we've got some record of X's, and we have some, I believe it was called an NP. We're here, SOP NP, full of identities. So we actually have the things for all the X's, and we're going to build up a get for this product. So what we're going to need to do is run through this thing and first navigate to the first child like we did before, and then repeatedly navigate to the next sibling, and then walk through. So if you have several children, it'll be walk down to the first child and then do next sibling, next sibling, next sibling, next sibling. So each one will be coming from the appropriate next sibling. And that'll skip past the tag. We previously were putting the tag sort of logically between the parens, right? So we had, well, we're only dealing with the one tag case, so the one constructor case, so we don't have any. So if I had a triple, it's going to get serialized like this with the data in between. And the trick here is that these parens are stored in that way that lets us navigate up and down in a one time. So we first need to get the first child, and then we're going to walk through with some kind of cursor. So I think we first have to walk down to the first child, and then that product will be at the right place to keep navigating forward. You steal this code because it's basically exactly what I want. We're inside at the appropriate child. And I want to keep moving to the right here. So first of all, let's do something that like walks down in and then does the thing. Down would have to do something like, you give me a get A and I'll give you a get A. And this is going to be DI let Shapely first child, DI in run get M DJ. This navigates down first. take a get action. So let's give this like a nice name and make it more generic. So how did Shapely get defined? Move is going to take one of these things. Range, min, max, storable, vector, word 64 to word 64 to maybe word 64. That's a mess. And then take a get a to a get a. And we'll just steal the logic for down and right. So move FM is going to be this thing, generalized. Get DI, Shapely F, DI. So I should be able to do like sort of down, move to first child, and then carry on with the products, which will then continue to first get and then move to the next sibling. I had to figure out that part. Thanks to them. That saved me some pain. I will probably just point to your repo for that. Right here, I've got a couple of Git submodules and stuff like that for things that I had previously forked in the last stream. This time, I'm going to be able to move to, because all of those have been merged upstream since the last time we broadcast. I'll be able to move to head versions of everything else, or like released versions of everything else. Get blob I to get, and then move to next siblings, and then this is going to be something like take an come on, give me a mouse. A's, and we're going to give an IA. I don't remember what the const was here. We were looking way back at the early example. Like I said, this is the first time I've ever actually used this library, so it's actually going pretty well. Const is the colon star. And to be honest, this is a state monad, so it doesn't really add a whole lot of value to not just say something like this. It's cleaner to read, even if it's got an unnecessary monad constraint, but it doesn't matter. So that gets us products. So now what we need to do is somehow handle the sum, which means we need to look at the number and then do something that's going to differentiate the type based on that number. So we're going to have to deal with sums very carefully. SOP all to gettable x's. We're going to get an SOPI x's. So what are we going to do here? We're going to have a number. And that number is going to be the, I guess it'll be a word 8, because right now that's what we're storing our tags as. So we first have to read out the be like get8 to read out the tag. Then we're going to do sums for that tag. And then we're going to convert from those sums SOP2 mapped over sums for that tag. So get8 would read the tag, which is right inside of our current parentheses, but the parentheses don't live in our data set at all, so that's okay. SOP2 sum. Okay. Now, if we're at 0, we're going to actually be done. So this is going to be an SOP applied to run products. But we first need to move to first child for run products. What is this X's? Products doesn't take an X's, it's just products. That's getting better. Move to first child, products. Sums K. Sums K, move first child, product. Sums anything else is going to be an SOP I don't really like putting on and taking off this SOP constructor, but we'll deal with it after. Case sums of k minus 1 of SOP X's SOP suck of X's. But now, so this is in a monad. So we have to do sums k minus 1. There, that's a mess. This should be an F map. SOP S X's. Ugh. Let's do this. What is this? Is it like an SOP? I don't care about that thing. X's, but with a something constant to it. Yeah, I believe that. On the other hand, I'm only going to use it the one time, so maybe it doesn't really make a lot of sense to give this a top-level definition. Fmap that thing over sums k minus 1. All right, what do we have here? We are looking at the length of the number of constructors we have. If the number of constructors we have is 1, we are not going to bother to encode a tag. The tag will always be 0. If the number of constructors that we have is more than 1, we first read off what the tag number is. Then we construct an entry for the appropriate tag number. So we find all the products. for that thing. We put a number of sucks onto that thing to be correct, and then we convert back from sum of products. Holy cow. And thank you, Buff and Fresh. By the way, for those of you who aren't familiar with Twitch, I know a good chunk of the Haskell folks are generally pretty new to Twitch. If you are an Amazon Prime subscriber or what have you, you can click the gift a sub button here. It doesn't cost you anything. You can do one gifted sub a month. It doesn't renew. And then the streamer in question gets a couple bucks or something from it. What do we have here? We've got gettable. We're trying to replace all of this generic gettable crap. That can die, that can die. And that could die. That'd be really nice. Not in scope, generic from, because that was in generics SOP GGP, I believe. To some code. Did I not do scope type variables or something? I did not. To some code rep A194 for all A. 95, what's wrong now? SOP code of A is a unit. We got length. We're going to need to do something fancy here. I guess we're going to have to... There's slist, which will get back the thing that I can walk, and then I can case on that rather than... This is requiring, like, magic insight to jump from the fact that this was a number. So we're going to have to be smarter about this. So again, GHCI, M+, generics SOP, GGP, something like that. Or generics SOP. Info slist. What did you do again? You gave back an info. You gave back an slist. What does slist look like? It's an snil or an sconce. So I need to look at the slist, not the length, and see if it's a sconce on an snil. So we're going to do sop.slist of this thing, and if it is a sconce, then we do this thing. Header matching on a GADT. Sconce should have no arguments. Sconce, oh, it just has the slist of the thing. That is annoying. It just knows that it's an slist instance. It doesn't have the it doesn't have the, doesn't contain the thing. So if I have an sconce, I should be able to, like, talk about how am I going to do this nicely with the case analysis on slist. what I want to do, there should be some kind of M plus GHC generics, and yes, I should probably slide the window over to the right, less Alex makes Mason complain about the positioning. Well, he will complain about for the first hour and a half of the stream, I guess. What do we have here? Oh, not GHC generics. Generics is P. TL takes an NP. What's the equivalent of tail for his S-list stuff? A lot of stuff in here. S-list I. Gets back in S-list. What else you got? The singleton instance would be better. Explicit term level representation of type level lists. Given an S-list I can give you back a shape. A shape actually holds the damn shape. Okay. So I want shape, not S-list. SOP shape of that thing should give me a shape nil. We'll have a shape const of a shape nil. Line 95, what's wrong? Proxy. Shape doesn't take a proxy. It's going to take some X's. We need to type applications. Now what's wrong? Spec to the type, but GHC SOP shape takes a thing, has kind, list of. That's fine. Turn all the polygons and data kind stuff just to make sure that that's not causing me havoc over here. That's not it. SOP shape. Yeah, shape does the thing that I was expecting. Shape const shape. Shape is uppercase. This shape here should be the lowercase shape combinator. Right here. That goes with the shape type. Hello, Light and Light. And it looks like I didn't notice, but Neb also found the shape thing. Crud. What else we got? So length S-list is just looking at the shape and walking down it. So they're doing the same thing that I'm doing here. So that's a good sign. We just need to get the right shape. Shape proxy X's to that thing is going to be an S-list I X's. What a nice name. Shaped, ignore that argument, is shape. Where did I screw up there? Colon. S list I. Importing crap qualified thing is with birds. If I have a shape cons of a shape nil, then damn it, SOP code of A is a freaking cons list. So I got in there. I now have a shape nil. Better not be a 0 in that case. Like, should it be? No, this should mean being paranoid. Things I don't miss about programming or debugging. Yeah, that's true, hon. SOP2, SOP, SOPZ. SOPZ should be taking this thing, putting it into the first constructor case, saying it's a sum of products now, and converting to. If all two are gettable, but we're only handling the shape const shape nil thing, so we're looking at SOPG code here. And walking it. So I'm missing leap in whatever it is that I need to do. Yeah, Random Nerd would have the answer for this immediately. Let's rule out our magic singleton case. X's is 110. SOP S X's. What am I screwing up on my induction thing here? I should be consing, right? If K is not 0, I want to increase and then work for U-type check. 109 still fails to type check. U-type check. U-type check. So all of those are not happy with me. As long as I have a sum of products that is gettable, I can read the tag and should be able to get you the sum of products. And we do so by, when we find the base case, we move to the first child and we decode it. And then we push it into the right index by doing this fmap. Here, sum of products. Products should be that thing. So we know all two gettable for the outside generic code for the thing. It's all too gettable, and we know that it's convertible. No, G2. First of all, that's not it. Could not deduce generic sum. Yeah, let's convert to. Anyways, that's a whole other problem. 110. We do all of this stuff, and then when we're done, we convert it back to a thing. Where does shaped come from? Shaped is defined right here. It's just shape with a proxy because, like, the shape that lives in generic SOP doesn't take a type argument to tell me what the type of the shape I want is. I guess in theory I could just shape is a shape of SOP proxy or that thing, and then get rid of shaped. And we're still getting the same problem, which is that line 99 cannot deduce that the SOP code is x const onto something when we open up the shape const. We should have learned that. Shape const should have told me we've got the SOP shape right in hand. Why didn't I learn the appropriate piece of information? What am I missing? I'm missing something stupid here, and I almost knocked my green screen over. Expected type SOP actually got an SOP rep. What is SOP? I haven't actually looked at the two codes. Maybe I screwed up something there. So what is G code is to sum code rep of that thing. G sum 2 rep A. And it should be just SOP G2. That's another problem. That might be the whole problem. All right. What is the shape we're using? We're using the SOP's generic code for A. Maybe go there. SOP, generic. No, generic SOP. SOP is just a new type holding onto an NS of an NP. So I'm going to switch some of this around just because it'll reduce some of the... I'll get rid of the SOP overhead. And then in the end, I'm going to have to a little bit better. Freed needs x0 and x1, 1 on 9. Sums k1. I think I might need to not just have the word, I might need to have the shape and do the induction. What, does that sound plausible to folks? If I had a shape for this x's as well. So if I had an SOP shape x's. So I have the word, I have the shape, I have the data. And then we'll do induction on the shape to walk down. So we have a 0, we have a shape const. Some other crap. We're just going to build a z, and we know that it's safe for us to build the z. Here, we know we have a shape const of some crap. Five, what did I screw up? I need to feed it a shape. Call n the shape, that way we've got it. Couldn't match type get. Gives us an NP of I. Set new. H probably know I really don't like using the colon set new because it messes with my workflow. And hello coding. Word 8. We have a shape. We know that they're all gettable. Shape will let us walk into the tail. We know that that tells us everything there's coding. Did I pronounce it right or wrong? Z, move, first child products, walk in, move, next sibling. It should be right. Get blob I. I don't need to get blob I. We're doing this in the monad. That was what I think that extra logic was. It's an SOPI. Hey, that's progress. It's an SOP const. How do we know that sums is not going to see a shape nil? If it does, then we screwed up in coding earlier. because we encoded something that didn't have any constructors, or like we encoded a tag that's outside of the range of constructors. There, it's a bad blob. Because we read the tag. This would be like data.binary reading a tag, and then this is just out of range or something like that. It's the tag that's really the culprit. Generic 2 bounded by... we didn't actually do the analysis to see whether or not we're done, did we? So we just need to look at the shape and do the induction. Because I didn't build a base case for products. So what do we have? We have one constructor. Move first product, products, shape. This will just take a shape and give us the get. So this would be a shape const x's. Products of shape nil is do return SOP nil. Does that look plausible to me? That's a SOP shape nil. Not in variable scope, shape. Products of SOP shape. Gettable doesn't exist anymore. All this crap doesn't exist anymore. Hey, compiled. So what we were missing was the induction for products. That is actually looking plausible. Moving to the next sibling to run the products is a little bit premature, though, because we don't know if that's a... Like, we should not necessarily move to next sibling to run a shape nil, because, like, move to next sibling... This is probably wrong. Because we're moving to next sibling to do the calculation rather than... we should do something like do the move to the next sibling for the get here. We've got an off by one error. We're moving to the next sibling too early. We're walking down to the first child. We know the first child exists. That's true. Come down here, we're doing a const. We should maybe do something like... This is inefficient, but whatever. If I have the last thing... And now we've got an induction principle that starts from 1. This should be, like, strided. That seems plausible. All right, so products. That will avoid the moving to the next sibling prematurely. Did we just write everything? Oh, and I can get rid of this rank 0 prime hack that we had to have because there was a bug in HW rank select. So, HW rank select, what did you have? There was hopefully a new release of this the other day. August 8th, that's since the last stream. New version. I think my PR was merged before then. Merged 5 days ago, and then shipped. So that's going to be the floor on our version. And then we can get rid of that rank select hack. So HW rank select, boom. That's input. So we had this little rank 0 prime, which we needed to work around a bug in the real rank 0. Alright, that's all fixed. And I believe the serial patch that we needed from last time was also merged. Package serial 057 was shipped. Yep, last week by Eric. Thank you, Eric. So serial 057 will be the floor. We'll update so we can actually see these things, and hopefully this will work. So, a couple of hours, we've been to switch over to a sum of products representation, hopefully. And then the major thing that we would have left would be starting to convert to having this thing on disk. I'm going to have to drop probably within an hour here, so we might not actually get to that done. We might not get to that part today. I have a GSOC student we're doing kind of like the final review for, so that's going to bite into my usual time slot. All new build, we've got all this. Thank you, new build. Go find the new constraints. What's wrong now? Constraint from user target requires. Why do you require Cabal serial? New configure? I don't know. What's the command? Done an update. Cabal new build. And this would be where it'd be handy to have Herbert. What's the stupid command here? I'm trying to do this properly so that I don't actually just blow away the cache, because like, that's the whole point of using a new build. Succinct binary demands serial greater than this. Next goal. Constraint from user target requires. I have like a Cabal project file that's complaining? No. Oh, do I have like I have it in my NIH folder still. modules kill the serial one. And I should be able to kill the HW rank select one as well. That's true. Wall project, you don't find anything in NaH right now. And then I will merge, I will use Teneb's branch of generic SOP, and that should get us the nil case so I can restore the void instance. Alright, well this is going, I'm going to go grab something to drink, hit the bathroom, do that, you know, random bio stuff. Alright, I'm back. The compiler isn't. Oh, it's still building bits. Bits has that coding thing that is incredibly slow. We don't really need the bits package. The only thing we were using out of it was like that coding thing, but the only thing we're ever doing is writing one bit at a time to meta and shape. We could probably get rid of that dependency. It would actually be a little cleaner and remove a lot of constructor thrashing and stuff like that behind the scenes. And it would remove this gigantic pause in our compile time. Because we're using put LSB by hand anyways, right? Go to binary succinct put. So the only thing we ever do is push bit. Our own push bit. So we use put LSB. And I believe we use a flush command that I have in there. No, it's in the blob module. Flush 8 is put aligned. So we use put aligned, and that's it. And the data type. So that might be worth doing at some point, is killing a little bits dependency. Because we're only using the coding type when we're using it wrong anyways, because it's got the wrong Indianness. What were we doing here? Rank 0. Oh, that finally came back. You imported rank 1, there's a rank 0 here. There we go. That's input. I usually have some syntax highlighting to yell at me when I've got trailing white space. Anything else here that looks obviously wrong? No. And we had some examples last time. Let's see if they work. Changed cups. Well, slid one in the other. Come on. Want to get up and push. Ugh. Come on. HWXS. Oh, I have two of these windows building. Come over here and do the new level. All right, we've got balanced parentheses. So we're going to need to get this thing out to disk at some point, and we need to check to make sure that it works. I think these are the two major hurdles remaining before this thing becomes almost viable. Now that we've got the sum of products thing fixed, I'm pretty happy. I wouldn't mind getting the bits dependency removed. And I eventually need to go through and set all of the greater than or equal to things everywhere. Why do we depend on... Oh, we use bytes because we're using bits. So bits and bytes would die as dependencies. Contravariant, I don't think we're using as a dependency anymore. We were using it for a little while for put when we had the little puttable, when we had the contravariant put class thing that didn't work out, or data type that didn't work out. Spool is simple enough that we could inline it. I'm just thinking about how do I strip down the dependencies on this thing a little bit. Contemplation, I have not had time to read your thesis yet. I bookmarked it, I opened it up, it's sitting in my to read pile. I've been a bit distracted this week. S get put M. Oh, they have new names now. What is it? It's in data serialize put. I think it's run put M builder. Was the name that they gave it when they merged it. Thank you, Eric, by the way, for that. Let's try one more time. And yeah, it was my birthday this week, and there was a bunch of silly stuff going on there, and then I've been organizing some stuff for Mary and kind of off doing non-code stuff all week. All right, data binary succinct get. All that compiled. Yeah, studying Chinese. It's coming along actually pretty well. Data binary. All right, so what do we need to do? We need to test that this thing actually runs. We had some examples from like days ago. I think it became run get. Run put. What's in data binary succinct put? Should have a unput'em and maybe a run put. No, it's in blob. That's why I couldn't find it. Data binary succinct blob. Load that module. Now, run get all this stuff. Here. It's not a valid thing, so these are get 8s. Sweet, it's totally crashing. So that didn't work. Why did you not work? Why are you crashing? Had at least one red flag pop up when I was going through. No. Okay, git commit no say. That'll at least get it up on GitHub. So it's not just me. Run put in builder. If I kill this thing and restart it, does it run? Alright. That got stuck because it was at old dependencies. It's one problem with GHCID, is that if you change the dependencies that it's building with, it sticks. Huh. So I done broke everything. I'm gonna make a a sort of all-inclusive module. Hopefully that'll get me everything. Why did blob load? I did put Succinct as the last one in the thing. Right? I guess it takes the first one? Ball, new REPL. Do your job. Mainly because I just don't want to keep typing stuff every time we restart it. Alright. Unget, get pair, get 8. Run get. That failed. First of all, come down to something simple. So run get 8. Okay, that was, I might have actually just had the wrong position. No, of course, the world's not that nice to me. Put pair, put 8. I don't want put pair anymore, do I? I just realized put pair and get pair shouldn't exist anymore. That wasn't testing any other things we wanted anyways. Put 8, put n, all that stuff should die. Put rens. Shapely FDI, move FM, does all this stuff, run get M. Power products, lift get, all this stuff should just work. Get pair, it doesn't exist anymore. What do we have? We have not get pair. We just have get, put, round trip should do something like run put A. For all there, I don't need any quantification, that should just work. A to blob. That's the one we already tested. Round trip should be the version of this that says round trip A, run get, run put that thing. So, with that in scope, I should be able to say something like round trip 0 is a word 8. Then blow up. So we're failing on products. We're failing on sums. But we did successfully round trip a proxy. And unit. Word 16s. So our leaves are working okay. We're handling sums wrong. Let's build the run put thing and see what we get. Run put either word 8. So what are we doing? We're scribbling a 5312. That's interesting. And then down in the shape. Why am I not seeing any shape data? I expect to see shape data here, and I'm not seeing anything. Did I fail to put parentheses when I wrote? Get a binary succinct put. Put parens is there. We put parens around the products. We put parens around this. Products puts parens around each one of the individual things. So we are putting parens, in theory, in gplit. So this should be the thing that is causing us to do tag products. And the products should tell us put parens for each one of the k children. But if that child doesn't have any fields, I don't have anything that's going to cause me to... I might have a problem with the decoding of the walking down to the child that doesn't have a thing. I would expect versus that if the third constructor didn't have any members. I might die. I don't think that's not my workflow. And the thing is here it's just going to be, here's a gigantic pile of binary crap. So I would need to just like build better tools to inspect the bit vectors and stuff that I have here. So putting a single pair of parens around whatever the product structure is. And what else do we want here? Sums is puttable. This looks fine. I'm actually kind of okay with the put. On the other hand, to get, what do we do? We're walking into, if we have exactly one constructor, we don't bother decoding the tag. We just know we are building the first tag for whatever this thing is. And we have a shape. Otherwise, we have a tag. We walk to that position. Here, sums says the base case is we walk down into the first child. So we might need the ability to have the first child not to have any content when we have no product. That wouldn't explain why this is blowing up on either. We could do some work here, like with debug.trace or something like that, and spew out, hey, well, look, we're trying to get from this position, and this is the tag we got. This is just me slamming some awful syntax into it or something like that. I just read tag. Let's throw debug.trace output in here for a moment. Do you build? And printf debugging. I have failed in my job as a functional programmer. And JFK sucks. M plus data.word. I didn't have round trip and scope. I have to recover it. Right 0, red tag 1. Left 0, red tag 0. So we're seeing the correct tag. That's not the problem. So you're doing a generic get. Get 8. Debug that trace, or trace show, get 8. Position I. Shoehorn that in. Yeah, usually I smash it all together with show and all this kind of stuff. Here I'm just trying to... because I'm only using it for like 5 minutes, just building the tuple and letting it show is enough for me to identify the thing. Trip. We'll write 0. So we get 8 at position 0, 1. That was our tag. But we're not making it to any get 8 inside of here. So we're failing before we... Oh, we're getting a bad shape. The one element product optimization input. So the one element product optimization isn't necessarily an optimization, it's just me trying to avoid walking to the next sibling. So there I just simply don't write the parentheses. Here the problem is that if I were to move to the next sibling to read the product, moving to a sibling that doesn't exist would cause this move to fail. Because next sibling has this bad shape, blah nonsense. So I'm not sure that that's the case. I might be misunderstanding. I might be totally off base. Read tag s sums that all makes sense. Boring, but it makes sense. Product nil. Done. Product singleton thing. Decode it, shove it into all this stuff. Otherwise, we know that we have something that's interesting. Move on to it. I think is sound. Get at the current position. We've already walked down into the first child, and I think this is a thing that when we go to fix up maybe and stuff like that, it's going to be broken, right? Because maybe is going to want to serialize as nil or a thing. And arguably, this should serialize as nil and a thing, and it's not doing that correctly. So this is, I think, what I want it to serialize as now. What I would ideally want this to serialize is as something like this. I think we need a pretty printer for the blob. What do you think? That does this output? No corresponding move in get. For one element products. So one element products. So we move to the first child. So that moves inside of here. So the navigation is for one element sums. I think that might be the... So it's whether or not we have a tag out here. But we walk to the first child regardless. No? Let me see if I can get this blob printer thing going. Because right now I'm thinking in mud and it's really not pleasant. So we're just going to run through the meta and Haskell Works data, so access or something like that, add index. Haskell Works data bits, no, rank select, CS Poppy. Should have an add index instance, I hope. Oh, come on. Why are you making this difficult? Form 0 to... Is there a length? Come on. CS Poppy bits times 64. CS Poppy. blob meta shape content. 0 to vector length of meta times 64. Screw it, it'll have extra stuff at the tail. So I don't have anything that tells it how to properly trim. I've got an index. For each one of those things, I want to access meta position I. If it's true, it's data. Or is it true as shape? Here's data. And we just want to scribble out a string of this thing. So I guess we'll just do like a work in the list method. I is each one of these things, K is each one of these. Scribble out a shape. Start there. I didn't actually import vector. Storable vector with Poppy. That's not a meta. What was Poppy's? CS Poppy bits. And access. CS Poppy. I don't remember what the index type is. I is going to be something like rank 1 of my meta type at position I minus rank 1 at of my meta type. Bool, and this will be like a from integer. 2 unum. It's going to be like a word 64. Those are my end. Fine, you're a from integral of that. Access compile. Haskell works, data. What are we doing? We're getting, I'm gonna have to wrap really soon here. Rank select rank. What the hell is rank? Haskell works, not data. Haskell works dot. Rank select. Base rank 1. V to count to count. I need to convert it to a Ah, your word 64s. Thank you, damn it. Variable not in scope I. We have some kind of access thing. Find but not used. Export blob. Couldn't match CS Poppy with blah 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 blah. Well, new REPL. I should now be able to do this blob thing on something that I've put. It'll at least give me a mixture of S and D's. Blob. Run put. Word. Run put right, and then I should be able to say, hey, blob that. Should show me shaper data, and it totally failed. Seg fault. That is lovely. So I apparently indexed out of range. Well, I'm using storable vectors and indexing in bad places, so. What are we doing? We're accessing M at position I. Rank 1 at S, position I. Storable length of that thing, of the poppy bits of that thing. I guess what I should do is just keep track of a number. So we should be able to know the number of things that we wrote to. We don't really have the length here. Because we crammed all this extra crap in it before we truncated it. Dot length in bits. What length? What dot length? Storable length is giving me length in word 64s. HW rank select base. There's a million little packages here. Rank select base internal. That's all the. Rank A, B. Rank 0. Rank 1. It's just, this thing takes account to account. And counts are word 64s, right? Yeah. I'm integral storable length. CS copy bits. This also might have bad things when you access it at position 0 or position -1. I was hoping to just use access, but I think the @ index or something like that is missing for Poppy. No, all I wanted to do is not round trip it, but lob. Word. Okay, so that's all the excess data that we have at the end. And then we just need to turn these into parentheses and the actual bytes. So here we have shape. So we're going to use rank. Rank 1, something count to count. So it's going to be rank 1 of shape at position I. Access S at position I. Get some more decoding. We're not going to access S at position I. We're going to access rank one MI. This is terribly inefficient. Doesn't have to be. Whee! Access S at position rank 1 MI. Shape or data. Count ones in that thing up to that position. Rank 1 something, take a rank 1 V, take a V word 64, bool rank 1 underscore I such that, or SI such that I is less than or equal to 0 is going to be 0. Let's just like extend this thing. That should extend the definedness of access, and then I can start at position 0. Maybe. Rank 1 SI. Give me word 64 to word 64. Defined but not used S. Maybe that'll work. Not using content yet. Import data word. Blob this thing out. Totally blow up. So I screwed something up. So tried to make a nicer rank 1. Hi, J-Light. We're writing in Haskell. So rank 1. So access here should be counting. Rank 1 of this, subtracting off from rank 1 smaller. Quesadilla Quantum, it's going pretty well, actually, other than the fact that the code that I'm trying to write now is horribly, horribly broken. So we did a big refactoring project today, and it broke a bunch of the things that I'm hoping to use. Rank 1 blob MSC. Da, da, da. And it's almost time to end the stream anyways. I have to, I'm going to have to bail out in probably about within 5 minutes. And I do think it is doable to learn Haskell as a first language. There's a number of books out there that are pretty approachable for where to start from Haskell. I think in some ways it kind of avoids you getting into some bad habits. So yeah, I can't say anything particularly bad about learning Haskell first. Access S. Why is that broken? Segfault. What I'll do is I'll say this currently segfaults. I will dump this onto GitHub. Add segfaulting blob filter printer. If somebody wants to make that thing nicer, I will totally accept the patch. And meanwhile, I guess I'll pick this up next week around this time. So, if you've been following along and want to contribute, please feel free to take a stab at trying to fix that. The code that we have right now is on GitHub at ecomet succinct binary. I will paste the link back into chat. I usually try to reach closure before I end, but I think today we're going to have to end at about this point. I have a pull request. What is my pull request? Fix copy paste error. Oh, you beat me to it. Reopened this 3 days ago. I think this should be closed because it was fixed. And again, thank you, everybody, and I will see folks next week this time. If I do a stream during the week, I'll try and announce it a day or so in advance, but it'll probably be something unrelated to this. And I will see you folks on Sunday.